What's up, guys? Welcome back to the Big Logan channel. I'm your host, Big Logan. So today is our electrical system install and full system design episode. This is going to be a part one of a two-part electrical install on the Peggy Ram ProMaster van conversion. So today we're going to focus on the installation of our main power supply components, solar alternator, charger, battery bank, and inverter, as well as going over the BigLogan custom electrical system schematic. So we're going to dig into the details of our full systems design. All that and more in today's episode. Let's get it started. All right. This is the electrical episode. So welcome aboard if you guys are new to the channel. We hope you stick around, like this video, subscribe to the Big Logan channel today. So on this episode, we're going to get started on the full DC electrical system, and I've already got to start framing out the left wheel well. That's where we're going to locate it. If you guys have already seen the previous episode, you know that the right wheel well, all the plumbing resides all along the right side of our Ram ProMaster here. So left wheel well, nice slim low impact over the wheel well area for all the electrical components, which we'll go over in more detail here in a minute. So one convenient thing I just found is a grounding lug on the van. So I'm going to drill through right under here and follow me under the van here. Okay guys, so right here, conveniently located on the left wheel well, is a ground lug. So this is the main chassis line. This is a unibody build, but this is still considered like the main chassis. Good enough to ground this unit back to the starter negative terminal. This is going to be considered our chassis ground for the entire system. So I went ahead and filed this off, cleaned it up, got this bottom face here of this pressed in stud or welded in stud down to bare metal. And I have a hole drilled out going up to our battery area right over here, just beyond that. So I'm gonna put this ground cable on, feed it up through. Okay. The factory nut that comes on this stud, you can see here, is bare metal, so it's ready for grounding. There we go. Alright, so now that we're grounded the chassis, that leads us into Peggy's full electrical system. So this schematic is broken out. This is the full design of all the electrical components. Direct current, DC, and alternating current, AC. So for today, we're going to cover the main power supply system and battery bank, and that's what we're going to focus on installing over that left wheel well. So one unique thing about this electrical system is the Renogy DC C50S. Solar and alternator charge controller. So what's really cool about this is it's all in one unit, solar and alternator input that regulates your battery bank voltage while also regulating your starter battery voltage. So it's the only system that I've found where you can take your solar panel and trickle charge all winter long or off-season time your starter battery as well. It'll keep both of these topped off and ready to go at a moment's notice, so that's awesome. The battery bank's 250 amp hours of deep cycle heavy duty sealed lead acid batteries. So this bank can also go up to an optional additional 250 amp hours. And the reason I designed it that way and reserve that space is in case myself or the next owner of this van, if we do happen to sell it, can modularly increase their battery bank. So this can also accept a full 4 battery or maybe 5 battery depending on the form factor of lithium batteries for a DC operated air conditioning system. So speaking of air conditioning units, we are actually going to go with a rooftop air conditioning unit. But how are we going to power that with such a small bank? Well, we'll have to add external power. So what's unique is the Artera WF8930 distribution panel, which I'll link below, has 2 separate bus bars. You can actually see them right here. So those 2 separate AC bus bars allow 2 forms of input. Now I'll have to split the actual common and ground bar down here with a grinder, but there'll be 2 separate AC distribution circuits. So by splitting this common and ground bar, we're going to be able to break out the AC side of this distribution panel into 2 AC buses. So those are AC bus 1 and AC bus 2. So AC bus number 1 will go through 30 amps and then break out into two 15 amp breakers. So breaker 1 will have common receptacles throughout the van and the Black & Decker microwave, and then the second 15 amp breaker will solely be dedicated to the water heater that pulls pretty high current. So AC bus number 2 is fully dedicated to our rooftop air conditioning unit, and here's why. We want to allow power input to come not only from solar or the alternator to keep the battery bank running, but we want to bring in external power in the form of shore power from a campsite, or powering an outlet from your house, or powering in from the bumper plug with a 2000 watt portable quiet running generator. So we don't need 3000 watts to run this air conditioner, and here's why. We're going to put in line inside the air conditioning unit a Micro Air Easy Start 364. So this is known as a soft starter. Without this unit, this portable generator would actually fault out and shut off. It would continually pop the onboard protection breakers because of that high amperage that spikes every time the compressor wants to kick on. Finally, we have our DC system. So that's going to again come right from our battery bank and power all of our DC electronics and components on board. So I have a brief breakdown of those right here. I can't think of anything else that we need right now. So this is it, guys. We have the Max Air vent fan, which is already installed. We did that in our window install episode. And we have our Isotherm Cruise Elegance 130, awesome DC fridge. Pulls about 1.5 amp hours, so it is going to be a low power running unit. In addition to that, we're going to add a water level gauge and power our water pump. After that, we've got our lighting circuits. So breaking these down, we've got circuits 1 through 4. Main cabin on a touchscreen dimmer switch, and the dinette, which will also be on a touchscreen dimmer switch. Those are going to power 2-inch LED lights. So circuit 3 is going to be right over the countertop over the cook space, powered by a local rocker switch over by that kitchen vanity. And then circuit 4 is going to be in the garage under the bed. We're going to dedicate 4 of those LED lights, make that a nice bright space. Finally, as far as lighting goes, we have bedside USB charger and reading light. So pretty unique little device. I'll link it below in the description. I got them in from Amazon and they look to be really nice and sturdy. They're made out of metal and it has a little USB port. You can charge your phone by your bed, and then also a little reading light. So guys, that breaks down the entire electrical system design for Peggy the Ram Pro Master. Let's get back into our main power system and test this system out. See if our main power supply is going to work. Let's get back to it. All right. So we've got all of our electrics laid out here. And first step is to get our 2-piece battery bank, 125 amp hour. I want to get these things mounted in the van over the left wheel well. So we already got the chassis ground cable penetrated through here before I got building and cramming this stuff full, so we're good on room there. This is the alternator charge coming off the positive terminal of the starter battery, staged and ready to go. And now I want to be able to cram up to 4 of those batteries in here, or any battery. So this bank is actually going to be modular and be about out to here. I'm only going to put 2 in to start, see how the system runs with the solar and the alternator, but have the capacity to come up to number 3 and number 4 batteries right over here. So that's next up. Frame that solution out, get a backing board over here for distribution for the solar charge controller, all the fuses, and we'll get you up to date. Let's do it. Okay, time for an update. So here is the layout for the main battery bank, inverter, and charge controller. So all the other distribution, which is going to run through this box, is going to reside right here. It has a nice flip up panel, so we'll have a black panel here to match our black shower panel over here. Solar charge controller, main termination breaker for the entire system, And then I'm gonna start running all my supply breakers, pepper those down here. And our 3000 watt inverter is living up top here. Good room for ventilation, so I just strapped it instead of putting another board under it. That way it can breathe really good. What is up, what is up? So we are making things with our crimp terminals, heat shrink, heat gun, heavy cable. So let me show you the progress tonight. Working under the lights. So we've got the charge controller placed, we've got the inverter placed, and the dual battery bank placed. And remember from our schematic, like we talked about, there's room here for 2 more batteries. We're going to do a quick breakdown on how to make a crimped end terminal like this. We're actually going to attach this from our alternator to the solar charge controller. I only have one of these ends prepped to help me get my wire management in here. So this is going to go right here on the top of this breaker and wrap around and come right to here. Get that nice and flat. You don't want to come off of a terminal with an immediate bend. There we go. Let's take a walk. So now we're going to cut this. Some loppers. There we go. Heat shrink. We're going to make sure these ends are cohesive, so it's going to make a bend up into that unit like this. So this head isn't this way or this way. It's flat with the other one in this case. Okay. We're going to take our whacker. It's our crimp tool. So we're good here. Right before you whack it, you want to make sure you hold it in. No copper showing. There it is. Fire up the heat gun. There you have it. You can see some of the glue actually pushes out here. So this is on very well, no matter how much we bend this. So that's our pre-made cable. Let's go put it in. All right, so we are here with our pre-made cable. Time to put it in here. This is coming from the alternator 80 amp breaker to the input in the Renogy solar charge controller. That's a check. A couple more to do. Rinse and repeat. Let's get after it. Okay, time to fire it up. Master breaker going on. Breaker for the Renogy charge controller going on. Aha, we got lights. Green per the service manual means we are sealed lead acid. That's what we got right here. So the battery mode's correct. Red is low battery voltage, yellow is normal or nominal, and green is fully charged, so it's in a storage charge, so that's proper. I'm going to turn the breaker on for the alternator. No alternator juice, the vehicle's not running. Let's go turn it on. Okay, let's see what we got. Alternator light is not on. Oh, it's on. Okay, so solid red means on. Alternator's charging the service battery. So let's fire up the inverter now. Turning her on without the remote. We are on. Take this in. We are now powered by our 2 house batteries. We're charging with our alternator and batteries are nominal in the bank. Everything's looking good, guys. That's a wrap for this episode. Next episode on the part 2 electrical install, we'll cover the solar panel installation and routing this whole baby out with all this beautiful electronics we went over today. Hey guys, thanks for watching. Hope you subscribe to the BigLogan channel. Like this video, comment below if you have any questions. We'll see you on the next episode. Peace.